Okay, so today we are gonna work on longest consecutive subsequence. So the question says, given an unsorted array of integer nums, return the length of the longest consecutive element sequence. You must write the algorithm that runs in big O of n time. Okay. Um, so the brute force approach for this seems quite straightforward. But that will be of time complexity big O of n log n, and the way we can do that is we sort this thing and then we just iterate through um, the numbers, and whenever we see consecutive numbers we keep a track of a count and we keep on increasing counter, and then we'll also keep track of the maximum value of that counter, and eventually we just need to return that maximum counter, and that should be the answer. For example, this one, if we sort this, it will be 1 2 3 4 100 200. So 1 2 3 4 till 4 we'll keep on increasing the counter because they are consecutive numbers. So we'll get 4, and our max will be 4, and then since it's the next number 100, the counter will reset to 1, and then again here reset to 1. So the answer will be 4, but the complexity will be big O of n log n. The question says you want to implement a linear solution for this. So let's see how we can do that. So linear solution. Linear solution means probably need to iterate through this list once and figure out a way to do it. Okay. One way that I can think of a solution is, and this is quite experimental, is using a hash map. So let's say we iterate through this nums and we create a hash map of every value. So for example, 100 occurs, 100 is there, 4 is there, 200 is there, 1 is there, 3 is there, 2 is there, right? Wait, 2 is there, and for every value we can just keep a count as 1. I guess that should be fine, right? And then we can do like a depth search solution, right? So we pick up one which is, let's say, 100, so any value out of this bunch, and we see if there is a value less than and greater than this in this cache or not, or a hash map. So 99 or 101. So we don't have either. That means for this 100, the maximum consecutive values that we can have is just 1. Similarly, we pick 4. So 4 itself is a number, and then 4 will provide us 3 and 5, right? So we don't have 5, but we have 3. So we'll increase the count here. We'll remove 5 because 5 doesn't have anything, and 5 will give us 2, and 4, since 4 is something we have already processed, so we want to make sure that we keep track of that. So we won't process 4, but 2 is something that is new and it's existing, so we'll take 2. 2 will give us 1 and 3. So we want to make sure that we always go uh, like less than or greater than, I guess. So we can probably skip the check for 3 as well every time. So anyways, 1 is there, and then 1 will give us 0. 0 is not there, so the count is 4. So I think this solution should work. um, yeah, so we can probably try that out. One thing that I've noticed here is, so let's just take an example of 4 again. So 4 gives like 4 will provide us two values. One will be 3 and one will be 5. Now if we see that 5 is not there, that means we can just skip this value. But if 3 is there, that means it's the left value, which is like the decreasing value. So we don't need to check for the incremented value of 3, that is 4. We want to keep decreasing it, until there is no similar value. And if let's say 5 were there, in that case we wanted to keep on increasing 5 until we find a value that is not there, so 6. And for 3 it would have been 2. Hope that makes sense. So we'll try to do something there. Okay, so first of all you want to create a map, so let's just say uh, tracker is equals to this, and then let's just use collection dot default dict, or let's just use normal map, that should be fine. Okay, so then for I in nums, what we want to do is tracker of I is equals to 1. So we just created a cache. So let's just say cache. I think cache will be better naming convention for this. Okay, so this is how we create cache. Now what we want to do is to make sure that we have okay okay, so we can use the same cache to make sure that we are not processing value that we have already processed. So let's just create a variable called max consecutive values, and just give it a value 0. Okay, then what we'll do is we'll do for I in nums if cache of I is greater than 0 in this case, or cache of I is equals to 1. In that case we want to process this, and here we'll do some function, right? So we'll just do something else, we just want to continue, and in the end we want to return maximum of CV, I think. Okay, so what do we want to do here, right? So what we want to do here is get left and right value and do some kind of a recursive operation where we keep on searching for that value. So it's basically while. So what we'll do is we'll do left comma right, which will be equals to I minus 1 and I plus 1, which is the left and right number. Okay, and we'll do while cache of left is equals to 1, or cache of right is equals to 1. You want to keep processing it. Okay, so let's say if cache of left is equals to 1, that means, so here also we want to increase this value to 1, because every number itself is one consecutive value and we can have left and right. So we'll just do that, and then here what we can see is, so if cache of left is equals to 1, that means so if cache of left is equals to 1, that means we can increase this value. So we can increase it anyways, I think, but actually no. So in this case we do that, and we'll do left 1 is equals to 1, right? Because we want to, if we go left we want to keep going left, if we go right we want to keep going left right. There's no point in coming in between, because we are spreading from the middle out. We don't need to track the value that is in the middle, I think. And then if we similarly we do it for right, so if right is 1, we do max 1, and then we do right plus equals to 1. Now one thing that is there is, what if some value is repeating, you know? So in that case, if for I nums tracker of I, so what we can do is yeah, so in this case what we can do is we'll do this cache of left is equals to 0, cache of right is equals to 0 as well. We don't need to process it. So what I was thinking initially was, why not just increase the count here instead of keeping it 1. So let's say if we have 2, or if we have 1 2 times, we can keep track of 1 as 2. So 1 has occurred 2 times and we can process both of those instances, but it doesn't make sense. It's consecutive numbers, so if 1 1 is there we cannot process it. should be fine, I think, this way. Yeah, something like this. And then yeah, so this loop should not be infinite, I think. So something like this, maybe. Tracker is not defined. Okay, I think it's cache. Okay. Mm, what? What does this say? Key error. Oh, okay. It's possible, right? Okay, what I can do is, if left in cache or right in cache, I'll just do that. I can do this as well. I think this will be better. Okay, what is this error? Bunch of error that I'm getting here. It's just not ideally good. Key errors. Okay. Left in cache. Like that. The reason for that is we are deleting all of these values. Okay, we are getting 6 here. For this we are getting 10. Why is that the case? Okay, can we do some debugging here? So can we just print out I? Can we print out left and right? What is the issue here? Not sure. Okay, so we start with 100 and 4. 4 give 3 5. 3 5 give 2 5. 2 5 give 1 5. And we get 100. Okay. Okay, I think I got it. This has to be, I think, reset. I'm getting C equals to 0. Oh wait, just answer. Okay, and then here, after this loop ends, this while loop, you want to keep track of answer, comma, maxi, something like this. Oh, what? Oh, yeah, okay. Having some trouble there, I think. It's fine, it's been a while, it should be okay. Cool. So what was happening was, while we were doing this depth first search or breadth first search, we were not keeping track of the maximum value and it was getting reset every time. So probably that was the reason for this. It should be linear time. Yeah, it is linear time, so I think we're good. Cool. Let me know what you guys think. Thank you.